Good morning, learners at home and viewers. I'm Dlulane, a teacher at High School. I'll be presenting mathematical literacy. Yesterday, I was presenting doing ratios and proportions, and I promised you that I will be doing measurement, but I felt that instead of doing measurement, I have to do maps and plans because there will be application of what I have already done. Because I'll be talking of unit ratios and scales, and I'll also be applying proportions. So today I'm dealing with the topic on maps and plans. Okay, on maps and plans, I'll specifically be dealing with maps and what you can be asked on maps. Okay, the first thing which you can be asked on a map is to give general directions on a map, and it's a question which will always be in a paper giving general directions. Though it is 2 marks, it's a question which you must not lose marks on. To give general directions, you have first to look at a map, because in a map there will always be compass directions, which is indicating your north. And north is the one which will be always giving you directions. Irrespective of where your north is pointing, what you need to do to make things easier for you, you always put your map in a direction so that north is facing your front. And then whenever you are going north is front, then it means when you are going towards you, that is your south. And always on your right, it is your east. And on your left, it is your west. And then when you are asked about general directions, I will make an example. Let's say you have Durban there, and then you have PE somewhere on your map there. Then you have on your map the direction, compass direction, and north is indicated. I've just told you that the north is the key which will always be given, and then always, if that is your north, down there is your south, and towards the right it's your east, and towards the left it's your west. Then what you do is you will be given what is the general direction of Durban from PE. Always look for the reference town. Like for instance, if they are saying Durban from PE, it means PE is your reference town. You are from PE. So when you are given general directions, what do? You first move straight from the town of reference. Straight, it will be either north or south. And then after that, you just move either east or west. So it means now if they are like that in the map, the general direction of Durban from PE, you first move straight north and then you turn east. So it means the general direction is northeast. But now if you are asked about the general direction of PE from Durban, it means now your Durban is the reference point. And I said you first move straight. You're moving straight, it's either up or down. Now when you are from Durban, you move down, and because north is upwards, it means when moving down, you are moving south, and then you move to PE. So it means if you take that direction, that is your southwest. You must be sure about those general directions. Now, the way they are asking it, like sometime you will have your PE, you will have your Durban, and then let's say you have your Pretoria there. They will ask, what is the general direction of Pretoria from PE via Durban? Give the directions which you will take when you are moving from PE via Durban to Pretoria. I've just told you that the first thing you do is either move up or down. So you will first move up, which is your north, and then you will move east. So it means your first direction is northeast. And then now, if Pretoria is there, the second direction, from Durban now you move once more north, and then it is northwest. So in this instance now we have got two directions, which is northeast, and another direction is northwest. Sometimes you will have a town which is directly above the other one, and in that case you will not have an east or a west, it will just be north, or if you are going down it will be south. You need to be sure about the general directions. It's marks which you do not have to lose. The next thing which will be asked is to give give instructions, in fact, for a person to go. Let's say you want to give directions to a friend, you are having a study group, you want to give general directions to a friend to your home. When giving directions or instructions for directions, you need to give clear instructions. With clear instructions, it means you have to mention the landmarks. But the first thing you do when you're giving instructions for direction is you start by giving direction which you take when you get out of your gate, exiting your point. So meaning the first thing we do, from your home, you either take your right or your left. Then from your right, you will mention, you either go straight, then if there is a street which you pass, you will say, okay, I will pass Dam Street, move forward, and then I will pass a church, I will pass a school, mention whether the school is on your right or on your left. And you just write simple sentences. And whenever you are asked about instructions for directions, check yourself when you are writing instructions. Check whether with the given instruction you will be able to reach the destination. So that is very, very simple. It just needs you to be able to just write simple, explicit directions. Then, on a map, the map is on paper, and map is representing distances between towns. But now when you have a map on paper, like for instance, the distance between East London and Port Elizabeth is about 300 kilometers. But on paper, you cannot represent 300 kilometers. So now in a map, we use a scale, and a scale makes you to be able to represent kilometers on paper. So you use a scale. With scales which we use, we have got two different types of scales. We have what is known as a numerical scale. I think that is leading you. The fact that it's numerical, it means it's in a number system. And then you've got a bar scale. I'm going to explain how to use both scales because you can be asked to use either of those scales. A numerical scale is given in the form of a ratio. That's why I thought it was very important for me today to continue so that you can see what I was talking about yesterday, how it is applied in other situations. So a numerical scale is in the form of a unit ratio. I'll make an example. When you have a scale of 1 is into 2.5 million. Okay, you have got that scale. 1 is into 2.5 million. So that is your numerical scale, a number scale, or a ratio scale. That's how we refer to it. It's either numerical, it's you can either say it's a ratio scale. Then for a bar scale, it will be like very small rectangles in that way, and then along the scale you will be having values. Let's say between there and there it's written 50 kilometers. Up to the end, it's written 100 kilometers. So it's in the form of bars like that. That is a bar scale. I am going to explain to you first how to use a numerical scale. Okay? In a numerical scale, first I am saying it must be in the form of a unit ratio. I explained yesterday how to get a unit ratio. That when you've got your ratios, to get a unit ratio, you divide both ratios by the first ratio. Because sometimes they can trick you by not giving it as a unit scale, where you have first to divide to get your unit scale. Then, what you do, you can, in a map, given a map, and then the question can be calculate or give the actual distance between two towns. You are given this numerical scale. How to calculate the actual distance. Then what do you do if you are given a map? If you're given a map, the first thing you do on your map is you measure the distance between the towns using a ruler. You use a ruler. So it means whenever you get to an exam, you need to have a ruler, because you won't know whether you will be given a map where you have to measure and calculate an actual distance. Let's say now for this distance you have calculated and your answer was 12 centimeters. A ruler is either centimeters on one side and millimeters. Those are the only units which are in your 30 centimeter rulers. So it means you will either have 12 centimeters on the centimeter side or 120 millimeters if you are using the millimeter side. So after you have measured using a ruler, the next thing you do is, okay, given scale is 1 is into 2,5 million. And then using a ruler, you have measured 12 centimeters or you have measured 120 millimeters. What you do is you will take your measured distance and multiply it by the unit scale, the second value on your scale. Then, after you have measured, after you have multiplied that, you will get an answer. So, if you are using centimeters, you will get 300, 1, 2, 3, 4, 5, and it will be in centimeters. Whereas if now you are multiplying using the millimeters, your answer now will be 3, 1, 2, 3, 4, 5, 6. And then now those are your millimeters. The question will be, calculate the actual distance in kilometers, for instance, because mostly that's how the distance is represented in reality. Then what you do, after you have multiplied by the unit scale, the next thing you do is you do a conversion. You need, as a mathematical literacy learner, to be able to convert between your metric units. That is basic. You can never get to an exam not knowing how to convert centimeters to kilometers and millimeters to kilometers. And then centimeters to kilometers, you have got 100,000 centimeters in a kilometer. So it means now when you are converting, you will divide by 100,000. And then your answer in kilometers will be 300 kilometers. Then, if you had used millimeters, there is a million millimeters in a kilometer. So now it means you will divide by a million. And then once more, you will be getting 300 kilometers. What I wanted you to understand is the fact that irrespective of whether you use millimeters or centimeters, it doesn't matter, because what needs to be done is how are we supposed to represent your answer. It will depend on what the question was. Then, I said I want this lesson to talk to yesterday's lesson. When you are doing conversions, you can also use proportion, because I did ratios and proportions. Like now, if you understand that there are 100,000 centimeters in a kilometer, you can, by just using your proportions, you can, okay? Let's say now you wanted to convert these centimeters to kilometers, okay? You had 3, 1, 2. Okay, centimeters. You want to convert them to kilometers. You know that, okay, what do you want? You want a kilometer. So what you needs to be on your right. So 1 kilometer is how many? Is 100,000 centimeters. So now, how many will be in what you have calculated? Okay, it will be just what I have told you, that what is on your right you multiply by what is at the bottom and divide by what is on top. And then once more, you will be able to do that by just using your, you can do conversions using your proportion. Okay. I think you understand how to use a numerical scale. Let me once more go through, take you through how to use a numerical scale. First thing, make sure that you are using a scale in the form of a unit ratio. You measure the distance between the two towns. You multiply by the unit ratio. You convert to the desired units. And I've just mentioned that it's very important for you to know how to convert from one metric unit to the other. That's what you have to memorize day in and day out. Because even when you are dealing with the topic on perimeters, areas, that is key. You need to be able to work within the units. Okay? The next one is a bar scale. How to use now a bar scale. Your map will at the bottom have a bar scale, and then whenever you are given a bar scale, it means you can be able to calculate distances between two towns. Because not all the time that you are given a map with distances, sometimes you are given a map without distances, and you have to use these scales to calculate your own distance. Then when you have a bar scale, what do? You take a ruler and measure your bar scale. So in this case, you have taken a ruler, measure from the first point to the last point on your bar scale, and let's say you got 15 centimeters. You know that 15 centimeters will be 150 millimeters. Okay, that is fine. Then, after you have done that, what do? You go to your map, and then on your map, you once more measure the distance between the two towns. So on the map, take a ruler, measure the distance. Remember, in a map on towns, they are supposed to be dots. The most accurate way is to put your ruler almost at the middle of one dot to the middle of the other dot, representing a town. And then, let's say for that measurement, you got on the map, you got 9 centimeters. The next thing you do now will be to use your proportion. That's why I said it's important to make a follow-up lesson on yesterday's lesson. Okay? You know that you have calculated 15 centimeters, you have measured. But the 15 centimeters, you measured it, but on that bar scale, it is equivalent to 100 kilometers. Then now you say the one which I've measured on the map is equal to how many kilometers? You use proportion once more. So it will be your 100 multiplied by what is at the bottom and divide by what is at the top. And then you will get an answer of 60 kilometers. Let's recap once more about how to use a bar scale. Measure your bar scale using a ruler. Measure on your map using a ruler. Use proportion. The value which you measured with a ruler is equal to the kilometers or miles or whatever is indicated on your bar scale. Then you use proportion to find out how much is what you have measured on the map. So that's how you do it. Then you can be given a bar scale once more, given a bar scale, and then now asked to convert this bar scale to a numerical scale. Okay, once more, let's use the same bar scale. 50 kilometers, 100 kilometers. Okay, one other important thing is you can either measure up to 50 kilometers or from the start to 100 kilometers. It does not matter. Ne? But now you are asked to convert a bar scale to a numerical scale. I'm going to use the same example, okay? You measured your bar scale and you got 15 centimeters. Then now, 15 centimeters of yours is equal to 100 kilometers. What is key is you can, this scale is in the form of a unit ratio, but you cannot divide when you are having different units. That is key, that is basic. That's why I'm saying it is important for you to be able to know conversions, because if you do not know how to convert between metric units, you will not be able to answer questions on scale, you won't be able to answer questions on measurement. Then now, you need to convert so as to have the same units. We already know almost that 100,000 centimeters are in 1 kilometer. Then now it means you have to multiply these 100 kilometers by 100,000 to get your centimeters. So now it means you will have, and then now it will be centimeters. The question was to change a bar scale to a numerical scale. Then after you have done that, now you can get your unit ratio. Unit ratio, you divide both values by the first value. Then you will have your scale now in the form of 1 to something, and then your answer will be 6, 6, 6, 6, 6, 6, comma, okay, 6, 6. And please note, a scale will not have units. Yesterday I mentioned something about rounding, which is very important because when you asked to represent it in the form of a bar scale, you can be asked to represent it in the form of a numerical scale rounded. Let's say now you were asked to write it in the form of a unit ratio and then rounded to the nearest thousand. I mentioned that on your whole number you look at the last 3 digits. In this case now, the last 3 digits are 666. Half of 1,000 is 500. So if it is 500 and above, it changes to 1,000 and you will add it to the next one. But now it is more than 500, so you will have 1 is into 667,000. That is your scale. You changed a bar scale to a numerical scale by measuring your bar scale, writing it as a ratio, converting to have the same units, getting a unit scale, a unit ratio, and then rounding depending on whether you have been asked to round. Okay? Let's look at this. Let's say you were asked to round it to 1,000,000. Okay? Now you have 666,666. And then what you do? The nearest million to that is just 1,000,000. So in the form, when you are rounding to the nearest million, it will just be 1 is to 1,000,000. That is very important, learners. You need to be sure about your rounding. Next thing which can be asked is, what is the meaning of a scale? What is the meaning of a scale? Given a scale, 1 is into 2,5 million. The scale which we had. Okay? Then, what is the meaning of the scale? I told you that a scale does not have units. But whenever you have a scale, it's saying 1 unit. Let's say it's in a floor plan, that scale which you are asked. 1 unit on the floor plan represents 2,5 million units in reality. So when you are asked to write the meaning, you just say 1 unit. It's representing. So depending on which units are written as your second ratio, it's 1 unit representing so many other units in reality. They ask that for 2 marks for you to explain the meaning of a scale. What does it mean? Then you can once more, okay, you can in addition, something additional, given now a drawing which is drawn on paper. Let's say for argument's sake, the drawing is written 3,6 meters. Now the question is, what is the scale written on, what is the scale used for that drawing? It's a drawing, and then in reality, that is 3,6 meters. But on paper, 3,6 meters cannot be there. So what do? You will just measure. Now, let's say you measure that using a ruler and you get 12 centimeters. The question now is for you to do what? To give a scale. Now you are given a drawing. You have to write the scale which has been used for the drawing. So I'm saying you just measure the distance on your drawing using a ruler. Then you will write it as a ratio. It's saying 12 centimeters is 3,6 meters. Scale is in the form of a unit ratio. Once more, you cannot divide by the first value because the units are not the same, so you have to make conversions. Remember what I've just emphasized. Time now, once more, that when the units are not the same, you have to do conversions. Can you see the importance of knowing how to convert? Okay, there are 100 centimeters in a meter, and then it means now for meters to centimeters, you have to multiply now by 100, and then you will have 360 kilometers, your centimeters, and then you divide now to get your unit ratio, because scale is in the form of a unit ratio. So you will have 1 is into 30. Once more, remember, a scale does not have units. Okay, before I move further, let's recap. Okay, what we have talked about in as far as maps and plans are concerned. Firstly, I talked about the general directions. Secondly, I talked about instructions to go somewhere where you have to mention the landmarks, the streets which you passed, and everything. And then, thirdly, I mentioned how to use a numerical scale. I mentioned how to use a bar scale. I mentioned how to change a bar scale to a numerical scale. And I mentioned how to write your own scale when you are given a drawing which is not drawn to scale. Then, I want to go further now and talk about application now of the distances in a formula, which is always asked. This is always in the paper, and it also encompasses some distances. It's a combination of measurement and maps and plans. The formula is familiar with those who are doing physical sciences. Its speed is distance over time. I want to integrate or incorporate it into this lesson because when you are to use this formula, or it can be written as distance is equal to speed multiplied by time. I want you learners not to think that it can be written in one way, or it can be time is distance over speed. One other important thing in mathematical literacy is you must not think you have familiar formulas. You have to be able to work on a given formula. Don't think because you are used to speed is equal to distance over time, and think that now if it's written in the form of distance is speed over time, and think that it's something different. What you are supposed to master is how to manipulate a given formula, not a familiar formula, but any given formula. The reason for me to mention this is when you are given a map and a map has a scale, it means that on that map the distance is given. So it means you cannot say when you are given a map and a scale and ask, okay, to use that formula, I have only been given speed. Where am I going to get the distance? So when you have got a scale, you can directly do your calculations depending on whether the scale on the map is a numerical scale or a bar scale. And I hope you have written some notes and you are sure about how to use either a bar scale or a numerical scale. So what I'm trying to tell you is, whenever there's a map with a scale, the distance is there. Okay, but I am going to give an example now where the distance is given. You have a couple visiting a town which is 350 kilometers away, which is 350 kilometers away. This is a familiar question. In fact, may not be familiar to you, but it's a question which is asked almost all the time. There will be a question where you need to use this formula. And then they stop for 30 minutes. Okay. If they are traveling at an average speed, at a speed of 105 kilometers per hour, will they be on time for a meeting at 11:05? Okay. Couple is visiting a town which is 350 kilometers away. They stop for 30 minutes. If they are traveling at a speed of, okay. One other thing which is different between maths and mathslit is with mathslit you will always be given a formula together with the question. There's no formula sheet, but the formula are included in the question, and it will say you may use speed is equal to distance over time. Okay, that's what will be given. What is important in mathslit is for you to be able to read and understand the question. I understand in our province that most of our learners are English second language speakers, and that's why you have a challenge with mathematical literacy. But if you understand the basic concepts, it's not about English as such, it's about you reading each sentence and translating it to your own language. That's what I always tell my learners, that read each sentence, translate it. You must know what the meaning of the sentence is. Write notes what is given. And you must always know that, okay, when it is saying kilometers per hour, it means it is speed. Kilometers, it is distance, because most of the time you find learners who are not able to understand what is given. You need to know that speed is given in kilometers per hour, distance is given in kilometers, and time is in hours. Because speed is in kilometers per hour, please remember, I always write it boldly that in this formula, when now we have been given the speed in kilometers per hour, you must know that the answer which you will get for time is in hours. Okay, let us carry on. Then, the way you solve your problem, okay, the first thing you write the given formula. You do not change a given formula. You write it as it is. Speed is equal to distance divided by time. Speed has been given, you go and substitute. There is a mark for substitution. Speed is 105, you substitute. Distance is given, and remember, I have mentioned that, okay, because now I don't have a map and a ruler, I will make an example where the speed is given. But now, if there is no given speed, but there's a map and a scale, you must know that you have to calculate your own distance. And then you have time. Okay. What is important in maths rates? I know that most of you stopped doing maths because there was that problem of solving for x. In mathematical literacy, I don't want us to say you are solving for x, guys. Please, I want you to make it a point that every time you want to leave what you need to calculate all by itself. But now, whenever there is something, I heard Mr. Njomini talking about the fact that the first thing he does when there's a fraction, he will multiply by the fraction. Then, that's what we do. For a clear equation, what you need to have is to have everything in one line. But always, when you want to put something on the other side of the equal sign, you do the opposite of what it is doing where it is. You have got time here. What is time doing there? It is dividing. Then when you want to remove the time, you will remove the time by doing the opposite of what the time has been doing on that side. Because now it was dividing. When you are taking it to the other side, it will do what? It will multiply. Then the next thing is, you need now to see what do you need to calculate. You have been asked to calculate. Will you be on time? So it means you have to calculate the time you will arrive. Then you have got a 105 multiplied by time. Then this 105 now is doing what? Is multiplying. You need to remove because you want time, so you have to leave time alone. So to leave time alone, you do the opposite of what was done on the other side. So it means because that 105 was multiplying, it will divide on that side. So you will have 350 divided by 105. And you will have 3,33 hours. Remember, the answer is in hours. Okay? There's something I forgot to mention on this, something missing. Okay? Did I mention that they left home at 8? I'm not sure whether I mentioned. Okay, let's say they left home. They left home at 8, né? And then they stayed on the road for 30 minutes. And then, let's say they had some lunch, some breakfast somewhere. They left at 8, they decided to have lunch somewhere. Then, we have calculated that it's 3,33 hours. Okay. Remember, now you have got 3 hours. 33 hours. The mistake which is always done by learners, they will say 3 hours, 33 minutes, which is not correct. These are all in hours, but now you have 3 hours and 0,33 hours. That is what you have. You have got 3 hours and 0,33 hours. And then what you do, you have to change this 0,33 hours to minutes. Then you will have multiplied by 60. And then rounded, you will have, okay, they've got 0,33 times 60. You've got 19,8 minutes, and you are allowed to round them to 20 minutes. Then you have your 8, which you left with, plus your 30 minutes, plus your 20 minutes now, plus your what? Plus your 3 hours. So now it means 8 o'clock you add 3 hours, 50 minutes. Then it means you will be able to arrive at 11:50. And then you won't make the time because you have been asked to prove whether we will be on time for a meeting at 11:05. For such questions, it is very important to make a conclusion. If you have been asked, show with calculations whether you will be able to make the time, make it a point that after you have done your calculation, you conclude and say, they are arriving at 11:50, they will not be able to arrive. They will be late for the meeting, or they won't make time for the meeting. In this case, sometimes you can be asked a question, where now? They are saying now, you take 3 hours, 50 minutes. You take 3 hours, 50 minutes. You are traveling at a speed of 110 kilometers per hour. You are taking 3 hours, 50 minutes, traveling at a speed of 110 kilometers per hour. Then you are asked, how much distance will you be able to cover? Okay, let's say now the formula for which has been given is, okay, speed is distance over time. Okay. Let's say now for just you have been given that distance is equal to speed multiplied by time. Okay? Distance is speed multiplied by time. Traveling at 100 kilometers per hour. Time 3 hours 50 minutes. Meaning now you cannot just do it as it is. You need first to change your minutes to hours. Another important thing, other than using proportion, you must know that whenever you are moving from a small unit to a big unit, you will always divide. And whenever you are moving from a big unit to a small unit, you will always multiply. Remember, when I was having hours and I was changing hours to minutes, I multiplied by 60. But now when I am changing minutes to hours, it means I've got to divide by 60. So it means now for substitution, you will have that speed, which is 110, multiplied by time. Your time is your 3 hours, and then you have got your 50 divided by 60, because you want your minutes now to be in hours. So you have your 50 divided by 60. And then now you will have 0.83. So it means it will be 110 multiplied by 0, multiplied by 3.83. Now it is in hours. Then you have 3.83 multiplied by 110. And then you have your distance, which is 421.3 kilometers. Remember, the point I want to put forward about this is whenever you are using this formula, you have speed in kilometers per hour, your time needs to be in hours. You need to be able to convert your minutes to hours and your hours to minutes. So it's very important as a maths lit learner to understand the conversions. That's what you have to memorize. It's very important to know these basics because time is one of the challenges. The chief markers are always complaining about the fact that learners are not able to add time, they are not able to manipulate time. And with these sharp calculators, there is an easy way when you want to add time. Let's say you have 30 hours, okay, 15 minutes, 2 seconds. You want to add 3 hours, 10 minutes, 5 seconds. On your calculator, what you do, you will say 30. There is a DMS sign. You say DMS, you go to minutes, DMS, you go to seconds, plus hours, DMS minutes, DMS seconds. I hope that at least by now you will be able to use your bar scale, your numerical scale, give general directions, instructions to go to your destination. You will be able to use the bar scale, the numerical scale. You will be able to change a bar scale to a numerical scale. You will be able to write your own scale when you are given a drawing which is not drawn to scale. And then you will be able to use the formula even if you are given a map and the scale, and even when you are given the actual distances. Hoping that these classes